since we talked about energy, what I want to do is now talk just briefly about energy per time, because that's the way we usually are talking about energy. We talk about power. So power is in units of watts. So power is in joules per second, which is what we call a watt. So when we talk about the power of our light bulbs, that's how many joules per second of energy it uses. So power, then, if it's energy per second, it's going to be work per time. So power is work over time. This would be average power. And then our instantaneous power, of course, is derivative of work with respect to time. Now, if your work is constant, then because it's burning at a constant brightness, then you just say, what is the work done over a particular period of time? And that becomes our power. There's one other way we can write this, just doing a little bit more math. So we can say our little bit of work would be our force times dr over dt, which I can rewrite as force dot dr dt. So this becomes our v. So one way to find the power is to say it's the work per time. Another way to find the power is to say force dot your speed, to find out how much power you've got, how much power is required if it requires a certain force to go some speed. Often, for example, if you're thinking about a car and how much force is needed to then get your car going at some speed, you can find the power that's delivered by your engine, for example. That's not going to be the total power of the system, because often you're going at a constant speed, as we talked about before, and so you're losing energy to basically air resistance. But that's not what you care about when you talk about your power of your car at that point, most of the time. Sometimes you're interested in power when you're accelerating, and sometimes it's just the power delivered as you're going along.